In this example, I want to create a special cut ditch at this location in the roadway. As you can see, the roadway is in a cut section here, and the shoulder slopes towards the curb line. I want to create a special cut ditch behind the curb by lowering this outside shoulder point down. The first step in the process is to create a horizontal alignment along that outside edge of shoulder line. To do that, I'm going to go to Geometry, Offsets and Tapers. I'm going to use the tool Single Offset Partial. And I want to set the offset to 0 because I basically want to trace this outside of shoulder line to create my horizontal alignment. I want to give this a name. This is on the Y2 alignment, station 24 plus 24 on the right side of the road. Follow the prompt. It says to pick the element. So this is the element I'm selecting, the outside edge of shoulder line from the corridor model. Then I need to identify the beginning and ending. I want to start about here, where my cut begins, and then end it about here. Now that I've done that, you can see that I now have created my horizontal alignment. The next step is to provide a profile for this horizontal alignment. So I'll select my horizontal alignment, go to Open Profile Model, select an open view. The next thing I want to do, I want to create what's called a 3D cut. I need to see the profile of this outside of edge of shoulder line. So I'll go to Create 3D Cut, select my placement method by corners, and then locate the start point and the end point. And now I can see the profile of this outside edge of shoulder line. 3D Cut will cut through everything that is included in your 3D model. When you create a 3D cut, make sure that you check your references to make sure that the snaps are enabled. So that I can then use that information for creating my profile. So now I'm ready to create my profile. I'll go to Geometry tab, under the vertical group, Profile Complex by PI. I'm going to start my profile about here, and I'm just going to snap to the existing outside of shoulder profile. I'm going to run this at a minimum slope of 0.5. So I'm going to use my right arrow key to change the input to slope and key in 0.5, press enter to lock that slope in. I'm going to run that to about here. And then I'm going to end the profile by once again snapping to the outside edge of shoulder profile, and then reset to complete the process. Then don't forget that you need to set this as the active profile. And then that will associate that profile with the horizontal alignment. At this point, I have a horizontal alignment and a vertical alignment. If I go to my cross-section view, you can see that that now shows up in my cross-section. And now this horizontal alignment and vertical alignment can be given to the roadway designers so that they can use this profile to then modify their roadway corridor model to create that special cut ditch. The next step will be to create a corridor model for the special cut ditch so that you as the designer can evaluate what the effects of this special cut ditch will be. Before creating my corridor model, I need to check to make sure that I have a template library loaded up, which I do. So now I'm ready to create the corridor. Go to New Corridor. Follow the prompt, locate the corridor baseline. Now I'm going to run my corridor along the back of the ditch because I want my special ditch profile to come off the back of the curb and come down here. So I'm going to select the back of curb line as my control. Now I want to reset for the active profile to use the back of curb profile from the roadway corridor model. I want to give this name, same name as the ditch. Next step is to select a template for the cut ditch. Press the Alt down arrow key. You can see I have some cut ditches available to use in the median or on the shoulder. So I'm going to select the shoulder on the right side, and there's my control point right there that I'm going to use to connect to the back of the curb line. Data point to accept that selection. Now I need to identify my start and end locations. I'm going to do this in the profile window. I'm going to snap to the beginning of my profile to start, and then the end of my profile. And then select an interval. I'm going to change this to 2 feet, and then data point to accept that. And now if I go to my cross-section view, I see my corridor model that has come in initially. And it is using the default template that I selected. And you can see that we need to make some changes. I want to convert this trapezoidal ditch to a V-ditch, and I want to change this back slope so that it matches this back slope. I'm going to make these changes using parametric constraints. I'm going to access those through the corridor handle, corridor creation tools, parametric constraints. The first change I want to make is to change the bottom width from 2 feet to 0 to make it a V-ditch. And I'll data point through to accept those selections. And now you see my trapezoidal ditch is now a V-ditch. Now let's do the back slope. And sometimes you have to select a couple times to get it to change. There we go. So I want to change this to 25%, 4-to-1 slope to match the roadway model. And then data point to accept the inputs. And now I have a slope that's matching. Now that I'm done with that, the next step is that I need to make this point follow my profile. And I'm going to do that using point controls. The point control that I'm going to add is going to control this point in the template and force it to follow this profile. Whenever you use point controls, it's important to make sure that you understand the template that you're working with. So I'm going to go to the template and take a look at it. So this is the actual template, and notice that it has a bottom width. There are 3 points down there. The way this works is it starts here and it works its way outward. So the point that I need to control is this point here, not the ditch middle point, but this point, ditch bottom in. I will control that point, and then the rest will follow. So to add a point control to the corridor. I'll select the corridor handle. In the flyout menu, oops, go to point controls and look at my dialog. I want to apply this to the beginning throughout the corridor, so I'll lock to start and lock to end. I'm going to give this a name, ditch invert. And the point that I'm going to control is the ditch bottom in, the inside of the ditch. I'm going to use a mode of both. You can use horizontal, vertical, or both. I'm going to use both because I want this point to follow my profile horizontally and vertically. The control type is linear geometry that I've created. And I need to tell it which one. So here's the geometry that's available. These are the roadway corridors, and this is the alignment that I created for the special cut ditch. When I do that, it recognizes that that alignment has an active profile. So I'm all done here. I just need the data point to accept my inputs. Now you can see that this template point is now following the profile that I created for my special cut ditch. At this point, I have a working corridor model that I can use to evaluate different design alternatives. I could evaluate different profiles, I could evaluate different back slopes or different widths of the shoulder, all through using parametric constraints. In this example, the template is designed to seek the existing surface. But it is often the case, especially in median ditches, that you would like to have your cut ditch seek a surface from the roadway profile. You can do that using a tool called target aliasing. It's found under the corridors tab here under the miscellaneous category. Define target aliasing. This allows you to add other targets besides the existing surface. So in this case, I'll go ahead and add my terrain model and my corridor, my roadway corridor, and hit apply. I'm going to go ahead and change my back slope to a 2-to-1 slope rather than a 4-to-1 slope so we can see the effect of this. To do that, I'm going to go to a tool called Corridor Objects. And this shows me everything that's in my corridor, all the different edits and changes that I've made. So for example, here under parametric constraints, I can look at the 2 parametric constraints that I've added and I can make edits to them. So I'm going to edit the back slope and change this to 50%, a 2-to-1 slope. You can see now how that has changed. I now have a 2-to-1 back slope. So let me go back to my target aliasing. And why is it not intersecting with my surface? It will intersect in the order of the aliases that are listed. So the first one that's listed is the terrain model, and it found it, and so it stopped there. I do have an option called this down here, this checkbox, use closest. If I do that and then apply, now it'll intersect with the surface. So you can use this to design ditches that will intersect with your roadway corridor rather than your existing surface when you need to. A handy tool in cross sections is something called temporary dimensions. In order to use this tool, however, your dynamic cross-section view must be built from a corridor model that is in your active DGN. It cannot be from a reference corridor model. So I'm going to create a dynamic view for this special ditch corridor model. I'm going to select the corridor handle and go to here, open cross-section model. I use the tool locate station via data point and look at this area over here. So now that I've done that, I'm going to right press in my dynamic cross-section view and go to place vertical temporary dimension. I'm going to snap to the back of the curb and then to the invert of the ditch, and then I'm going to indicate where I want the information to be shown. Now it is showing me the depth of that ditch. I'm going to go to View Properties and say Center on Current Offsets. And now I can step through along the special cut ditch and see what the depth of that ditch is along the entirety of the corridor, and see how it increases and decreases as I move along it. You can also use this tool and for horizontal measurements, place horizontal temporary dimension. So from the back of the curb to, let's say, the top of the cut slope. And I can pull that information off as I step through. So that's a very useful tool.